Okay, the session is now recording. So let me just for the sake of those who probably watch it later, let me just quickly run down through what I said previously. So Python is a universal language. It's easy to use and it has very large support. So it's you can easily find help online when you need it. I mean, from sites like Stack Overflow, you can easily Google what you need to do, and chances are that someone has probably solved or answered the question you need. So using the original package or the original formulation for Python is kind of difficult because you need to hard code everything. So we use a distribution called Anaconda. With Anaconda, it comes with pre-installed libraries, and you can also install libraries at your convenience to solve the kind of problems you want to solve, basically. So for Python for data science, the major thing you need to understand is exploratory data analysis, meaning you have to understand what your data is about. You need to analyze and investigate what your data talks about, what's in your data, basically. You understand your data. When you understand your data, then you can apply it, you can then use it to, you can then use that knowledge to solve problems, basically. So you do that by summarizing the major characteristics, and then you visualize and try to see what information you can extract from that and what you can actually apply that to, basically. So for
hello yeah, host.
Yeah, sure.
Sorry, we can't see your screen.
Oh, really? Okay.
Yes.
I'm sorry. Oh dear. That's weird. Can you see it now?
Yes, we can.
Okay. I'm sorry about that. Okay. Maybe let's start from. Okay. Yeah, just start from here. Okay. So for Python for data science, I mean, typically for Python, we have different libraries that you can use, right? But these 5 libraries are written that you can see on the screen. And I would like to call them the major ones. So if you have a good understanding of how these libraries work, I mean, you probably understand how to use Python more than 60% of the time. So for this, not today alone, but all through, we'll be using these libraries, basically. So briefly, we have a library for numerical calculations. That's when you are working with arrays. I'll explain that data types later. Then if you have data, let's say you have an Excel file or a CSV file or any data, basically, if you need to open that file to analyze the data in it, you need a library called pandas. Then if you need to visualize data, matplotlib does the trick. Then if you want to look at statistical models like box plots or maybe like mean mode and all those things, then Seaborn is a library to go to. And for machine learning, we have scikit-learn. There are many more libraries we have, but I mean, if you know how to use it very well, the other libraries will be a lot easier. So typically, in using Anaconda, basically, so Anaconda Navigator itself has that's the distribution itself. There are packages in it. We have Jupyter Notebook, we have Spider. So for beginners, I usually recommend Jupyter Notebook. Why? Because it's very interactive. It's easy to use. It makes things kind of straightforward. With time, when you become more advanced, you can then use Spider or you can use IPython. That's using the shell itself. So for today, we'll start with Jupyter Notebook. So in doing this, the way to open that, you just type Anaconda, then open, then click on open. So if you do that, it opens to this page. I'll give probably like a minute or two for anyone who needs to do this. Then if you have any question, you can please ask. You can unmute yourself and ask. That's fine. So if you've gotten to this page, this is, if you can see where my mouse is, this Jupyter Notebook is what we need for now. later we can probably, explore how to use Spider. So the thing is, the code is the same. The only difference is the, call it the interface, so there are certain variations and depending on what you need to do basically. But for this, what we need to use, or what we are using here is Jupyter Notebook. That is this one. So if you've opened this, then click on launch. You see launching notebook to open. My computer is a bit slow, but to open. This is a web-based interactive computer notebook environment. It's going to open in your browser. Mine typically opens in Edge. Some could be Google Chrome. It just depends really. Does anyone have any question? I guess everyone has come to this page as well too. So. Okay, so in opening, so this, if you can see this clearly, this like, if you see this page, basically it's, this doesn't need to work with the internet. You only need the internet to download and install, but it opens in your browser. It's kind of interactive and makes it kind of very easy to follow through and see what you are doing. It's like I call it bottom or the top-down approach, basically, but it works in a sequence, basically. So if you can see this page mirrors, the directory you're working on. Like if you scroll down, like this is mine, basically, right? So all these are in my, so if, for instance, you open your page, like if you're using Windows, you go to like this PC, this user, then this. So this, this directory, or this place is actually exactly what is here. You can see to this, exactly it's the same thing. So that it just opens in that directory. So anytime you need to, if you need to use any file that you want to access from Jupyter Notebook, it has to be in that directory. So to open a Jupyter Notebook, so to get started, if you look at the screen this is my right, new Python 3, create. It opens in another tab. Mine is a bit slow. I guess yours might be a bit faster, but it's opening on that tab basically. So this is a new environment. So for this, so this is Jupyter Notebook. This is called a notebook basically. Yeah, Jupyter Notebook. So typically, good coding practice, first thing is to rename it. What I did here is Untitled 61. If you are new to this, yours might probably be Untitled or Untitled 1 or something. So with this, you could just write, okay, I have something, maybe Python basics. You can call it anything. Just for the start to the enter and rename. And that's that, it changes that automatically. So, mark user. How do I get to? So let me see. So I think for Mark, if you open Anaconda itself, if you click on Jupyter Notebook, it should take you to this page directly. You don't need to, it take you to this place directly. You don't really need to enter this local, you don't need to. I don't know if I'm answering your question. So the file we just opened is, I guess everybody saw how I renamed it to Python basics. You can call it anything basically. This file now, if you check through this directory, it's here. And this just which we Control F, Python basics, and this is it. You can easily see it here. Let me just close this. So this is it here. If you notice, there's a green, I call it icon or so. But the green notebook, it shows a green notebook compared to others, meaning this is valid, or this is currently in operation, or this is currently open, why these are all, they are closed. So it already shows that this has been created in this working directory. So that's that. I hope we're all clear on this, basically. So for this,
sorry, please,
yeah,
can
sure.
you show me how you got to this page again?
This page, okay. Here. But are you clear on how I got to this?
Yes, I'm clear.
Okay, so new Python 3. You click on Python 3, it opens another one. I mean, it opens a new.
All right, thank you.
Yeah, then you just rename. So, okay, I guess, is everyone here already? I'll try to be slow as possible at this beginning class so you can easily understand. So, let's see. So if you can see this is called a cell. It's just one. If you can add another cell by clicking on this plus button, you see the, I don't know what this is called, but you can see insert cell plus. You click, you add another cell. You click, you can always add cells as you want. You can also delete cells. If you want to delete a cell, you can come here. The moment so if you click on this cell, it's green. The moment you click on this plus, it turns blue. Right, then if you press D twice, it clears off. Or you can come to edit, delete cell, it goes off. So if you this edit, so either you come to edit, delete cell, and either you click on this or you select the cell and you press D twice. So you see there are lots of help on exactly what you need to do, basically. So so for each cell, okay, let me explain this briefly. So for a file, typically you can open another notebook, it opens in a different page. You can make a copy of this same notebook, you can save, you can change the name. Let me leave save and checkpoint for now to be probably. Then you can also, when you're done, you can download your notebook into different formats. Typically for this notebook, it's this IPYNB or LaTeX if you're trying to do, to convert to mathematical stuff and everything. Python, that's if you want to use Spider or a different format, basically. So you can download download that. You can download that. Edit, you want to copy a cell, you want to cut a cell, copy, split. There are different operations you can do as well. Yeah, it's okay. So you can also decide to insert a cell above or below. Just maybe you have a cell here, you want to, insert cell above, put one above or below, depending on what you need to do. So if you want to run the cells, basically, you can just execute the code in one cell. That's for run cell. If you want to do that for everything in the notebook, run all, run above or below. Basically, that's just what that does. Okay. I'll explain this later if you need to. If you need to restart your program or clear variables, but let me make it as easy as possible. So for the cells, you can write code. You can either write code or write text, right? So for code, it has to be Python code, obviously. But for text, you can write. That's normal English or just normal things you need to write to help. And it's a way of helping you understand maybe what you've written what you're trying to do, or maybe just notes for your personal use. So if we look at this place, we have code, we have cells for code, and we have Markdown. So if you want to write code, it has to be code. If you want to write normal text, it has to be Markdown. So let's Markdown, basically, you can write anything you really want to do. Right? This is a Markdown, right? So in running any cell, you either use run, or you use shift enter, basically, depending on which one is convenient for you. So this is a Markdown cell. Then this for a code cell. Now, if you try this, for instance, let's see. For a code cell, if you write text in a code cell to throw up an error, do that, you see, throws up an error, syntax invalid error, because this is a Markdown cell for text. Text, you can write anything you want. it doesn't recognize. I mean, it just recognizes it. It doesn't really bother about what happens, right? But for code, it has to be Python code. So that's why it throws up this error. Okay. So in the Markdown cell, you can write anything you want. If you want to like headings, if you want to write a heading, hash, is that sorry? Yeah. Hash first, then the heading. Sorry. So what I just did is I made this bold by making it a heading, right? And I put a hash in front of it. That's what I did. Made it bold by putting a hash in front of it, basically. So let me see. Yes. And you just run it. You either run or shift enter. I prefer to use shift enter. It's easy for me, basically. So that's that. If you want to reduce the size of the font size, you just add another hash to it, and that reduces. Want to do more of that, add another hash to that, and that reduces. That's basically how for text, right? If you need to write things in italics, let's say you put an asterisk first. Let's just say that, shift enter or run, and that's that. If you need to, let's say, if you want to make something bold, you put double asterisk, shift enter, and it becomes bold. You probably are not seeing me on your screen going to click on run, but it's the same thing. I'm just using shift enter, so it's the same thing as run, basically. So that's how to write in a Markdown. Now in coding, I guess, I don't know if you're familiar with coding, typically you write comments to like give you hints on what to do and everything. In a Markdown cell, you can write any comment you want. Or in a code cell like this, if you must write a comment, let's say, okay, let me do something else. If you write this, it throws up an error, right? Because this is a code cell. But if you must write a text in this cell, you have to use you have to comment it. By commenting it, you put a hash. You put hash in front of that. So by the time you run this, it doesn't see it. It assumes this does not exist. I hope that makes it clear. I don't know. So if you're new to coding, probably you don't know that. You probably have not seen that. So anything that has this hash in front of it, the program does not see that. It's just for you to, you can see it, but it doesn't see that. So even if you are doing anything general, like for instance, 2 plus 2, you calculate that as 4, right? It assumes this does not exist, but it can see this because this is part of the program, or part of the code. Okay. Let's see what next. Comment code here. So if you want to comment a code, you just put hash in front of that. And this is okay. So for instance, if say a equals to 2, and 3, b equals to 5. So with Python, these are inbuilt commands. You can easily run this and you see how it works, right? So in more detail, I'll explain this later, but you are simply assigning a number, to a variable, right? Just make a equals to 3, b equals to 5. Simply writing a plus b. See, it outputs the result as 5. So one thing is this: if your code is running, you will see an asterisk here. Like you see, this cell, we've not executed or written anything here. This cell is empty, right? So let's assume, okay, let's do this. Just to save this. So if you look, okay, let's change. So if you look at this cell, there is no number in here, right? It's not, that's this cell has not been executed. So if you run this cell, you see an asterisk here before the results, before you see the results. Now, it might happen very fast because it's very simple for the code to do, for the program to do, right? So let me just do that. If I click on run, see, okay, it happened very fast, probably. Okay, let me show you with something else. I'll make it easy to understand. I'll explain what this command does very soon. Let's see, shift. So you can see it's running. You can see an asterisk. That's to tell you that this cell is being executed. So when it's done, you turn to the number 7. It will take a while because, so this code, what this does is we are trying to see the programs that are the libraries that have been installed. Probably take a while. Okay, it's done. So if you remember what I did say at the beginning, with Anaconda, you have some packages installed already. If you want to see a list of the packages you have already installed, you do that pip list. I'll explain, much later what that is, but if you just do this, you probably will see all that. It opens all the libraries you already have. If you scroll down, I don't know, I guess what I see on my screen should be what you see too, except maybe there might be some new additions to mine. But if you scroll down, you can see all the packages. Let me scroll down to the familiar ones we already discussed. Like for instance, you can see NumPy here, right? So on the list on the left is the library, the list on the right, and the list on the right, on the column on the right is the version type. So from time to time, probably we need to update these versions. So that NumPy, so that's that basically. These are all the programs, or all the libraries you have installed. So if you want to close or close this list, if I put an asterisk in front, that's to comment this. So if I run this, it doesn't see this, and this will vanish. So if I do that, run, that vanishes. So the aim of having this asterisk is, or commenting code basically is just to help you follow through what you've done and what you've written, basically. I'll write some very easy commands of things you can easily do so that it will be easy to follow. So if you want to print something, remember we're in the code cell, right? If you want to write something, typically print, that's brackets, then if you're writing anything text, they are strings, right? Hello world. Let's see. So what I've just done is this, because this is a code cell. Print, we need print. That's to say print what is written here. Yeah, you can see you have what's it called? Yeah, inside brackets, basically. Hello world. So this just prints commands, basically. It does print command. You can also combine your calculations with, we can ask you to print what you have just calculated. For instance, let's do this. Let me copy this. Copy, paste here. Okay. So print sum A and B is okay, so what I've just done is this, right? I've defined the variable A, that means A is equal to 2, B is equal to 7, right? Now I'm asking Python to print the sum of A plus B. Now this is how I write it. Print it, that's to execute, that's to ask it to.
The light one.
Can somebody please mute the microphone? Okay, let's continue. So we have A is equals to 2, B is equal to 7. We've defined that already. You're now asking print the sum of A plus B, right? Look at how look closely at this and how I've written it. Print in bracket, normal brackets. Then text is in, well, I don't know, it's crazy comma or confused. Yeah, yeah, but basically you don't just write this because it doesn't see. It has to be in quotation marks, right? Or yeah. Yeah, quotes, thanks. You're right, exactly. So it has to be in quotes. So the sum of A and B is, then bracket A plus B. And you see that you don't need to explicitly write A plus B is equal to this. It just computes this and writes this as a sentence. So this is what you can also do. Let's say you run your code to solve any problem, or so you can do this basically. That's just one thing. Then another thing, if you want to run, okay. So this, let's see. If you want to make sure that your DOM comes in a separate line, we use new line, separate, comma, I think it's slash, and this. Right. Okay, nice. Okay, I know I made a mistake. So comma, this. See. No. I want to do something else. Okay, so if you want the text to to be in two separate, that's the other one to go to the next line, right? Hello, it's in quotes with a comma, then word. It brings this down to the next line. This slash n is for the next line. So these are just some basic things, that with time you need to do, but I'm just showing them to you. I'll make this notebook available. So in case you need to use it, then you can also see. So if you want to also check your working directory, because it's your working directory, you're going to always keep the files you need to use, right? CD, run. You see, prints out, that's mine. Still the same thing, I think present working directory, this still does the same thing. That's one. Another thing is, okay. Was client. So let's docs. Let's see. Yeah, okay. Okay, so if in Python, if you want to use a library, you have to first import it, right? But for today, we wouldn't talk too much about that. I just want you to grab the basics, basically. But see, I can use, so this is an inbuilt command. I think OS should be operating system. So I import that, then I can print the login. So if you log into your computer or that's a user directory, yeah, so this code just brings that out basically. So you can see in quotes, hello, comma, that's this hello there. Then this is a command to explain that it's like go through a class, then a method, then it brings this out. So if you do this for your computer, it should work. It will work actually. That's just exactly to show you let's get login. That's yeah. Then for a code, this is still a code cell, right? The message number of string for Now this is still a code cell. I'm just showing you different variations. I can write for a text, it must follow with a quote, or else it's not going to, program, the code will not, it won't see it, right? Then for a number, this is string 774. So it prints all out. That's it. That's in one, basically. If I want to get rid of the quotations, I could use print, then brackets, then let's see if I copy this, it should work. Shift enter. And you see the difference, it gets rid of these quotes, basically, print of this. I don't know, different. Some people say it's not good to copy codes. I don't know, but just make sure what you're copying, you're sure of what you are doing. When I mean copy codes, copy from one cell to the other, right? So you see this is just a different method. It just writes this same thing without the quotes. The difference is we use print. Okay. Okay, I've explained how to add and delete a cell, how to define a variable. Okay, so let me explain data types. Let me explain data types. Return this to Markdown. I'll just explain the basic data types to make it easy for you. So Shift Enter, Python. So let's start with a list. List. So let's say we go, okay. So the first data type I'll talk about is a list. I just want to, for a list we use quick strip brackets. So a list, basically, a list is a collection of elements, right? So in this list, you have different numbers. It could be numbers, it could be text, it could be anything, basically, in this list. And in this list, one way to easily remember this is that we use square brackets. So for lists, we use square brackets, and first collection. Collection of elements. So this is a list. So this list, our list has numbers 10, 20, 30, 40, 50. And in this list, the name of the list is my list. You can call it anything, basically. So if I run this cell, right, just let me use this, run. You see, it shows that this has been executed. But if you want to print out the results, you type my list. Then if you run this cell again, it prints out what's in the list. So this is what the list is, but it has square brackets with them. If you want to confirm that, you write type, then my. So if you type my, then if you press tab to show you, it gives you hints of variables that have been defined, right? My list, then you run that. It tells you that it's a list, basically. Now for this list, the name of the list is my list. Yeah. So for this list, you can access the elements in the list. And one way to do that is by using the square brackets. So in Python, the index begins with 0, right? So if we type my list 0, shift enter, it gives us 10, which is the first number. That's the first number in the list. If we use, let's say, 4, it gives 50. That is 1, 2, 3, 4. If you type a number that's outside the list, it will throw up an error trying to, for instance, if I type 6, yeah, okay. It's a list index out of range because this is 0, 1, 2, 3, 4. Right? So if I do 2 runs 30, that's 2, 0, 1, 2. So that's how to access the numbers in the list. So you can also take a slice. I think it's called slicing, in the sense that if you type my list, we want a certain number. Let's say the square bracket. One from index 0 to 3. This one is written 0 to 3. to give you, so what to expect this to do is from numbers from here to, from 0 to 3. Okay, that from 0 to 3, meaning the first one is not part of it, but to give you up to this one. So I expect it to give us 20, 30, 40. If I run this, oh, sorry, let's see. Oh yeah, okay. Sorry. The 0, this is the first one, actually, it's part of it, but is it the third one that is not part of it? Because 0, 1, 2, right? So it, not 1, 2, not 3. So it runs, it gives us this. That's what the list basically is. It takes a slice from that. You can also do the same thing as this. Let's see. My list tab, square brackets. Let's say 2. Yes. So it gives us from the index 2 to the end. 0, 1, 2, 3, 4, 2, 3, 4. That's 30, 40, 50, which is this basically. So these are just basic operations you can do with a list. And list is a collection of elements, and they identified with square brackets. Let me see. So it can also be, it can be numbers. For instance, this can also be a list. Let's try this. Square bracket 1, comma, let's say B. Shift. So that's also a list too. You can verify this by type X. Type is to find out what type of data data type is that. Okay. Shift enter. Then prints out the list as well. I hope there are no questions. Okay. So the next type is dictionary. So for dictionary, we use curly braces.
I have a question.
Sure.
Okay, so for the data type, the list one, right?
Mm-hmm.
Can it also take text while we use the string? Or is it just number?
Can we also use text? Is that your question? Yes, we can. Like, okay, yes, we can. Like this. Okay, if I let me modify this, right? So it should be A like that. See, so like this, I'll modify that, and it still shows that this is a list basically. So yes, you can even then for this you can check. Let's say 1 to print out B. So this is 0, 1. So yes, you can. It's not limited to numbers. It can also be.
Thank you.
Yeah. So for a dictionaries, they use you're typically identified with curly braces, right? Use curly, let's see, curly braces. That is this symbol. So this is symbol basically. Yeah. Key pairs. So for a dictionary, we have pairs. It has to be pairs, in pairs, right? We have like a key and its pair. Let me give an example. Okay. Fruits, curly braces. So it's your string. Orange dash this. See, sweets. That's one. Now, another one should be this. So, two, third one. Just anything. It doesn't matter. Just to explain about it. So how dictionaries work is that they have to have a key and a pair, right? Like for instance, you can say oranges, they are sweet, apples are sour, berries, they're just random, right? It's like, I don't know, right? Is it, yeah, just like pairs, like you are correlating one to the other one to the other, like that. So it arranges it in that format. I replace an element. Yes, you can replace an element in a list. Okay, I'll explain how to do that. I'll explain that when I get to that point. So, so in a dictionary, we have, with curly braces, and we can identify them in pairs, basically. Yeah, you can group them in pairs. Let me see. Okay, for instance, so this is the dictionary itself. Just to verify it's a dictionary. Type fruits. See, run, and it shows dictionary. That's what it means. So for the type fruits, see, brackets. So if you remember in list, we're indexing them, or we're trying to locate the elements in the list with numbers, with the index. But for a dictionary, you have to use the text itself. For instance, for this, I have to use, let's see. I don't know if that's clear, right? So this is dictionary itself, fruits by the index orange. So oranges it brings out sweet. If you look at this very closely, this is, the first one is this is the key. This is the pair, right? That's pairs, they are in twos, right? Like this, see this, basically. So if I do, let's see, fruits, again, tab, this. So if I do, let's see, berries, shift enter, it brings out random. So this way you can access the values in dictionary. So ideally you can have very large dictionaries, right? A dictionary can be very large. Of course, you're not going to have you won't have the ability to access all through this. We probably use like a for loop or so, but you can just verify at certain locations the key and the variable that's in there, basically. Okay, another thing you can do is this. So if you do, I see, is it? Okay, fruits, that's the name of the dictionary. Dot keys. This. I'll explain what that's just. If you do fruits, again, dots, start this. Okay, now value. So this is another way to assess it, right? So the fruits dot keys. That's keys and pairs, or keys and values, right? Dot keys. Then with the normal brackets, open and close. You see, it gives us oranges. It gives orange, apple, berries, orange, one, apples, berries. Those are the keys. Then the values, sweet, sour, and random. Sweet, sour, random. That's what it does that as well too. Okay, let me show this. Try something. Please, if you have any question, you can ask. I'm sure if you. So if you look at this, right, we have one key and variable for orange, sweet, apples, sour, berries. They have more than just one, right? So how do you assess this? Like you're having a list inside this dictionary. So if you look at, so what one thing you can do is fruits. Ideally, if you do this with square brackets, then the tab. See, it brings out this, but you can be more specific if you want any of this one, because this is then, because this is now, you can now access this using the index, the numbers basically. If you put square bracket, let's say, so see, it specifies to 0, 1, 2, it picks this. So that's just another way you can, if you have like this list inside a dictionary. So if you have, let's say, 1, that, shift enter, different, you get that. So then the final dictionary for today should be tuple. The tuples are sometimes they can kind of difficult to understand, but I'll try to make it easy. So for these ones, they are defined in normal brackets. Normal brackets, that's this. That's how you they're defined in that. That's with that. So if you have, so okay, I'll explain the difference between that. So if you have, let's say, numbers equal to this normal bracket, right? So that's a tuple bracket. If you type numbers, see, it returns that. That's a tuple. So now I'm trying to explain, the difference between a list and a tuple, right? So if you use, let's see, lists, right? I think the right was that they are mutable. So they're not mutable. So one can be changed, one cannot be changed, right? You can modify one, you cannot modify the other. Apart from the fact that you can see clearly with the brackets. So numbers, for instance, is this number is a tuple. If you let's create, okay, let's use a different name. Random. Then for a list, is square brackets, right? So that is, let's see, make it different. I'm just in a new cell. So in this numbers, this is a tuple bracket. This is a list, right? So if you want to run, just write it down. Numbers down, random down, shift enter. Number. Okay, I think this overwrote this one. Let's do it separately. This one. So this for numbers, then put this here. So you can see the numbers, the brackets are different, right? Now, the brackets are different. One has normal brackets, the other one has square brackets. One way to differentiate them is this. So if you type numbers, let's say numbers dot tab, you can see we have count and index. There is no append. If there's append, then that's append means you are trying to add to what you already have inside. If you cannot add to that, then it's a tuple. So that this clearly tells you that this type is a tuple. So if you can also, you can verify that by type this, right? So you cannot add to, so these numbers 1, 2, 3, 4, 5, you cannot add to what you have inside. But for this random with square brackets, you can add to that. I'll show you. So by numbers, so for these numbers, put a dot, there's numbers dots, then press tab, you see count and index. So let me explain, what does count do? Okay, I can remember. So with count, let's see. we can count the number of, if you have an idea of what's inside the tuple, you can count the numbers, right? For instance, if you have one, count to return one because you only have one inside. If you're, for every value you add, it always return one because the number of four in that tuple is one. So it will still return one for this as well. Let's see, number here. So that's for count. If we press tab again, we have index tab. I mean index, then this. So for this, it can return the index, the corresponding index. If, for instance, if it's 0 for a number, I expect it to return 1. Let me see. Let me see. Okay, X is not a 2. Let's see. Okay. Yeah, okay. Yeah, it doesn't start. I don't know why it didn't start from 1. Anyways, yeah, it just returns that's the index, the first number, which is where is that? Oh, I see. Okay, I get it. So for this index, the number 1, it returns the index of the number 1, which is 0. The number 2, the index is 1. The number 3, the index is 2. So it returns the corresponding index. I guess that's what. So that's what that does basically. So however, for a list, it's totally different. The list we have is random. Let's just verify, type random. If you run that, it's a list, right? Yes. So if we type random.tab, you can see we have append there, trying to tell us that it's a list. With append, you can modify what's in that list. So if you type append, let's see, I don't know, where is the random itself? Okay, let's add the number, let's just say 60. So if we type random now, you can see number 60 has been added. This is it, 6, 7, 8, 9, 10. Or with append 6, 7, 8, 9, 10, 60. This is 60 we just added. So there are many options with using random to, you can probably play with them and see what they clearly do. You can clear, you can copy, you can count. Count the number of numbers. You can extend, you can, different things you can really do. Sort, you can sort from the highest to the lowest. I think it has a default basically. So that's what you can do with that. Let me see. Yes. So if you want to move, so one thing, if you want to move cells, for instance, let's say you have a cell here, like this cell. Once you click on the cell, it's highlighted here. You can move it up and down, but you have to be careful, know what you are doing, right? So you can look at these arrows, move selected cell up, move selected cell down. That's one thing. Now, okay, let me show this again, pip list. You can see, so sometimes you might want to do a certain analysis and that library is not installed by default, right? You can install it you can install it from, there are many ways to install it. Let me just show you how you can do that here. So let me just do installing the library. So this pip install. So what you do is pip install, then the name of the library. I'll explain more with details how you can install programs using pip or conda. There are different ways. I don't want to confuse you today. So you can install a program by doing this exclamation mark, question. There's no exclamation, this question mark. Right? Pip install. Which program can I think of? But I guess if it's been installed already, you see requirements already satisfied. But let's just try Python, shift and stuff. So when it's running, you see the asterisk here, right? So when it's trying to check if it can find this. If not, if it can't find it, then to install. Or if not, the entire requirement already satisfied. Any questions? Okay, yeah. So because I already have it installed, you see it, right? Requirement already installed. So when eventually you need to install any program, all you need to do is exclamation mark pip install the name of the program. The one I was trying to install is IPython. We already have it installed. So it writes requirement already installed, and it just writes a bunch of this. Then if you want to minimize this or hide it, just put hash in front of it, shift this, then it hides all of that. And also, if you sometimes you probably need help to understand, maybe let's say something, let's say print question. Okay, so that pops up. So you want to know how to use print and what it can do. So I just type print question mark, and opens in a kind of a different window below. It's print. There's different ways you can actually use it, right? Values, print the values to string. I mean, just different ways, and it's a built-in function. Built-in function in the sense that you don't need a library to use it. So that's that, I think. So I think we close this here. P. Let's see what it shows. Okay, I think, yeah. So if you have a variable, I think we've already used the letter B, so it's been defined already there. Then it opens that B is an integer string format, just gives you more information about it too. Yeah. So if you probably want to, I mean, it depends. Sometimes you can have variables that are clashing. Maybe one code is overwriting the other. You can come to, let's here, cell. Yeah, you can come to cell, all outputs, clear. So what this does is that it clears, like from the value of a plus b is defined as 8 already. Some values are defined, b is 7, I think, or 5. Yeah, b is 7 based on the second one. So you can clear that. So if I click on clear, if you take a look at the screen, square of those numbers in square bracket by the left will all clear off, right? You all clear off, meaning it's like a reset. You've cleared everything. So you can also decide to run you can decide to run all the cells at once. You come to cell, run all. And it's a run from the top. As it's doing that, it does that. You see the asterisk starts from, it starts from the top, the numbers, then the asterisk will keep moving till it gets to the bottom. Let me do that again, starting from here. So you see what it was. So cell, all outputs, clear. The moment I click on run all, the asterisk will be there. It starts from the top to the bottom, run all. Okay, yeah, it shows from the bottom, but you see the numbers will start populating as it runs. Yeah. So that's. Yeah, I think that should be all for today. So I probably don't give too much stuff to. Next week, I'll explain how to use the pandas, right? Yeah, pandas with the data set. I'll look for a data set from either Kaggle or UCI and explain that. So that should be all for today. Any questions? You can just unmute yourself and speak.
Good evening. I have a question. Is this all we need to learn before we move into the data sets where we get to use the pandas? Like I'm also going to learn stuff like list compression and like the important things that will take us into working with data sets.
Yeah, I will explain that, right? But the point is I'm trying to go at a pace that it will be easy to remember. If I explain list comprehensions today, a lot of people will probably not follow, right? Yeah. So the thing is, I'll explain list comprehension. I'll explain how to use functions, how to make, that's classes, methods, and everything. But I'm taking that the pace that when you go home, at least you're going to revise all this, so that you don't learn, because you can learn so many stuff and remember nothing, right? So I'll definitely explain list comprehensions. So for the pandas, like if you have a data set, maybe you are given a data set, you want to for data manipulation, you want to read it, you want to see what's in it, you want to plot them or everything, matplotlib and everything. So I'll explain all that. Then writing functions too, I'll also explain how to do that. these comprehensions or even how to use Lambda and everything. But the point is, try to go at a pace that's, because a lot of people said they don't understand how to do the basics first, but eventually we'll get to that part. Is that all?
All right. So, hello, I have a question.
Sure.
All right. Thank you so much for this class and all that. But question I wanted to ask is, do we need to learn all the necessary libraries like pandas, matplotlib, and seaborns before we venture into machine learning and all that?
Yes. So the thing is this, why you need to learn it, because I mean, even if you are doing machine learning, right, you don't just feed your data into the machine learning model. If you do that, I mean, it throw up, because it throw up errors, right? Or it probably give you false results. So here is the thing, if you're working in a company and everything, no company is going to give you processed data or clean data. You have to process it first. You have to, typically if you're working in industry, you have to explain what you can see from the data and why machine learning is important. But you cannot explain why you need machine learning if you cannot really explore your data. So if, like for instance, if I use the data that is Python or Jupyter Notebook, they have some inbuilt data sets in there. Most of those data are clean, right? But if you have, maybe you're working in a company and they give you like data for you to analyze, that data can probably have missing rows, missing columns, some values are suspect, some outliers and everything. You need to be able to process them and explain why you have to remove that, and then why you are using machine learning to do that. You can't do that if you don't know how to use pandas, NumPy, and all that. You have to know how to explain the data you have first. I mean, that's the first thing. In fact, a lot of if you're working for a company or even if it's a startup, the most important thing, you have to explain to them what you can see from the data before you begin to explore. Because people don't, to be honest, some clients don't understand, and this data set, I can use machine learning to do this, to do that. I mean, tell them this data, this is a trend I can see. This shows that there's possibility that this can explain this. And you cannot do that without understanding NumPy, pandas, and everything. So, I mean, there's no way I'm going to teach you everything, right? But like I showed in the PowerPoint, those libraries, if you know how to use them, the point is, if you know how to use them on a basic level and you're able to Google what you need to find, or you know the possibility of what something can do, then it's easy to find your way and understand it basically. So for machine learning, yeah, I mean, most of the work I do currently, I have data sets, right? But if I apply them to my models, they throw up errors. I mean, the result doesn't make any sense to me. So I can't convince anybody that it makes sense. I have to first explore that data, plot them, see, okay, this outlier, is it important? Is it telling me something I need to know, or I can remove them? If you see real world data sets, you can have like, one advantage, for instance, of using Python over like Excel, you can have data of millions of rows, right? If you have millions of rows with Excel, there's a limit. There are limits to that, but with Python, you can explore that data to the end. But how can you then, of course, you can't open all of that and check that one by one. But with Python, you can be able to understand you can explore the data in a way that you can convince someone that this is what this data is all about. This is what I think I can do with it. And all that. I hope I'm able to answer your question.
All right. Thank you, sir.
Sure. Okay. Okay, I can stop the recording now.